to the Chapter 11 Part 3 notes. This is the last notes of the whole year, actually. So in Chapter 11 Part 3, we'll be doing 11.6, which actually comes to you in two parts, and 11.7. So 11.6, we're looking at the surface area of spheres. So our first objective for this section is to find the surface area of the sphere, and our second objective, which will be our second part of 11.6, is to find the volume of a sphere. So starting with our definition of a sphere, we had mentioned this earlier as a three-dimensional circle. This is if I take a circle and I were to spin it. So like if you look at a spinning coin, the shape that it makes is a sphere. So in 2 dimensions, if I have a center and all of the points equidistant, that gives us a circle. If I have a center and all of the points equidistant in 3 dimensions, that is a sphere. Just like for 2 dimensions, if we go from the center out to one of our points on the sphere, that is called a radius. And if we go all the way from one point on the sphere through the center to another point on the sphere, that is a diameter. Now I've drawn them at kind of a strange angle. I didn't draw them straight across because I wanted to demonstrate that the only diameter is not through the center of the circle, thinking about it as what we call the great circle, which is the circle that goes kind of around like the equator. I can go in any direction. I could go sideways this way and create another diameter or a radius. And so it doesn't have to be kind of through like the halfway point vertically for the circle. It just has to go through the center of the circle. So to find the surface area of the sphere, what we can think about is if we take a baseball, which is a sphere, and we rip out the seams, the shape that we get is kind of like this. And if we take the seams out of a baseball, what we see is actually 4 circles. And so the area for the surface area of a sphere is 4 pi r squared. So if we look at a sphere and we break it open, we can find that the surface area of a sphere is 4 pi r squared, right? Surface area is squared. Now, these practice problems, we're actually going to come back to them. We're going to do them at the same time with volume. We'll find the surface area and volume for each of these together. So we're going to look at the second page, number 8, and this is the only problem that we're not also going to find the volume for. So for number 8, find the diameter of a sphere. If the diameter of a sphere is 27 meters, what is the surface area? So we have a sphere, which we can draw as a circle, and then we do kind of like a diagonal circle through it, a little arc, and then dots to show that it's on the far side of the circle. The diameter here is 27 meters, which means that the radius is half of that, 13.5 meters. And so to find the surface area equals 4 pi r squared. 4 pi are numbers, our radius is 13.5. When we square that, we'll find that this is 729. Pi, area is squared, so square meters. Again, we'll do more surface area examples after we define volume. So let's look at the next page to define volume. Now, normally these notes packets are not done on the same day, so we'll just write in these same definitions again. The sphere is a set of all points equidistant from the center. If we go from the center out to one side, that is a radius. And if we go all the way across from one edge through the center to the other edge, that is a diameter. The volume of a sphere, imagine we have this sphere and we fill it up with water. The volume is all of the space inside. Now, when we were looking at prisms and, for example, a square prism, which is also called a cube, compared to a square pyramid, we had the relationship is the prism is 3 times as large as the pyramid. Well, we're going to use that same 3 in order to find a sphere. Now, from a cube to a sphere, we divide it by 3, but you're taking the relationship of the surface area. So the formula for the volume, we have that 4 pi again. This is volume, so it's r cubed, and then we divide by 3. So commonly we see it as 4/3 pi r cubed, or 4 pi over 3 times r cubed. Cubed because it's a volume. Okay, so as a reminder, I'm going to put the surface area formula up here. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. So let's take a look at these examples. Now we're combining this with the ones that we skipped, volume and surface area for all of them. So in our first example, we're given a radius of 3. We'll find the volume first. Volume is 4/3 pi r cubed. Substitute our radius, 4/3 pi times 3 cubed, and we'll get 36 pi. Our units are feet. This is a volume, so it's cubic feet. For surface area is 4 pi r squared. Again, substituting in our radius, 4 pi times 3 squared, and 9 times 3 gives us 36 pi squared feet. I think I said 9 times 3. 9 times 4 is 36. Okay. For our second one, we're given the diameter all the way across. Diameter is 16 inches, so the radius is 8 inches. Let's find surface area first this time, just to show we can do it in whichever order. It won't affect the answer. So surface area is 4 pi r squared. 4 times pi, substitute in the radius. 8 squared times 4 gives us a total of 256 pi square inches. Volume is 4/3 pi r squared, cubed. Volume is cubed. So that's 4/3 pi. Our radius is 8 cubed. We want to leave our answer exact. So for this one, when you put it in your calculator, you'll need to ask for it back as a fraction. And that will give you 2,048 thirds pi. Or writing it as a single fraction, 2048 pi over 3, either way. And those are inches cubed. Cubic inches. For number 3, same thing, volume and surface area. For number 4, volume and surface area. I'm going to give you a chance to try these ones, and then we'll go through them together. So for number 3, I'll go ahead and do volume first. Volume is 4/3 pi r cubed. That's 4/3 pi times my radius, which is 7 cubed. Putting that into the calculator, we get 1,372 pi over 3. Our units are cubic centimeters. Third power for volume, surface area, 4 pi r squared. Substitute my r is 7. And we will get into the calculator 196 pi. Again, this is an area, so it is square centimeters. So the exponent on the units tells you what dimension you're calculating. Area is flat, that's 2-dimensional. Volume fills up space, that's 3-dimensional. And lastly, our number 4, I'll just choose to do surface area first, kind of alternating. This one is a diameter, so we need a radius, which is 12. Surface area is 4 pi r squared. Substituting 12, that's 4 pi times 12 squared. 12 squared times 4 gives us 576 pi. This is an area, so it is square yards. And volume is 4/3 pi r cubed. Substitute in our radius, which is 12. And simplify that, we should get 2,304 pi yards cubed, or cubic yards. Let's take a look at the next page. So for these problems, again, we're going to find volume and surface area, which I'm going to abbreviate SA. So volume and surface area to the nearest whole number. So we have a grapefruit. A grapefruit is approximately a sphere. The circumference is 14 pi. Circumference is 14 pi. Circumference is 2 pi r. So if I divide both sides by 2 pi, we get that 7 equals r. We have a radius of 7. We've actually seen this before, but we'll solve it again. So if we have a radius of 7, let's find volume first. Arbitrarily, volume is 4/3 pi r cubed. Substitute 7 for our radius. Put that into the calculator. 7 cubed times 4 divided by 3 gives us 1,372 pi over 3. Our units here are centimeters, so that's cubic centimeters for volume. And then surface area, that's 4 pi r squared. Substitute in our radius, and 7 squared times 4 should give us 196 pi. Area is squared centimeters. For number 6, we're doing something pretty similar. We're going to find a radius, but this time we're given a volume. Here we were given a circumference. So I'm going to, again, draw a picture. Here is a sphere. The volume of a sphere is 4/3 pi r cubed, and I know the volume is 140 pi. So how do we solve for r? Let's divide both sides by pi. And then this is a fraction, so it's a little harder to see, but 4/3 r cubed equals 140. In order to remove a fraction, I can multiply by its reciprocal, creating a factor of 1. So multiply both sides by 3/4. The 3's will reduce, the 4's will reduce. We're left with r cubed equals 140 times 3 divided by 4 gives us 105. Now here's the trick. I want to find what number cubed gives me 105. And the way to do that is to take not the square root, but the cube root. So before we could take a square root, this time we're going to take a cube root. And so r equals, how you do that on your calculator, is you go into the math menu. So second alpha math, go into math. And option 4, or it might be 4 or 5, I think, depending on your calculator, but you're looking for the one that has a 3 in front of the square root. That's the cube root. So I'm going to go down to option 4. You can also just press the number 4, enter. That will give me the cube root of what? I want the cube root of 105. Enter. That's 4.7. So r is approximately 4.7. Round to the nearest whole number. That is about 5 centimeters. Okay. On number 7, this one we're looking at Earth's equator. So if we look at Earth is approximately a sphere, the equator goes all the way around. So the equator is a circumference. The equator is a circumference, which is 24,902 miles long. What is the approximate volume of Earth? And we are actually going to do volume and surface area. So here we have our circumference, we need our radius. To get that, we know that the formula for circumference is 2 pi r. Divide by 2 pi. R equals, again, we want to leave it exact as much as possible, so we're going to leave pi in the denominator. So we're really just dividing 24,902 divided by 2, giving us 12,451 over pi. We're going to use that as our radius, that fraction there. So let's find the surface area first. Surface area is 4 pi r squared. What we can do is we can type this whole thing directly into our calculator, but we need to be careful with how we use our parentheses. Our radius is 12,451 over pi, and then square it. So when we type this into the calculator, you want to type 4 pi, open parentheses, 12,451 divided by pi, close parentheses, and then square it. That will give us 197,387,017.5, rounding to the nearest thousand. So we have 197,387,000. So that is approximately 197,387,000 squared miles. Let's do the same thing for volume. Volume equals 4/3 pi r cubed. So when we type that into the calculator, we'll put 4/3 pi in parentheses, 12,451 over pi, and then cubed. So that's 4/3 times pi. Because there's no parentheses, the pi is back in the numerator, times 12,451 divided by pi, end parentheses, raised to the third power. To raise to a power, we use the little exponent underneath the clear button, raised to the third. Enter 2.607. At the end, that E11, I think we talked about this before, that means that this is given in scientific notation, meaning we have to move that decimal place 11 times. So we'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 more. So when I write my answer, this equals 2,607,66,435,500. Because I moved it 11 places. I can double check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that worked out. Now I want to round to the nearest thousands. So that's 260 trillion, 766 billion. Sorry, I miscounted my commas. 1,000, million, billion. 260 billion, 766 million, 430, round up 6,000 cubic miles. That is the volume of the Earth, approximately. And our last one here, the volume of a sphere is 5,000 pi cubic meters. What is its surface area to the nearest square meter? So we start with the volume, which is 4/3 pi r cubed, and we know that is 5,000 pi. Let's divide both sides by pi. So we get 4/3 r cubed equals 5,000. Multiply by 3/4. We find that r cubed equals 3,750. In order to find r, we need the cube root of both sides. So r is, and then I'll show you how to type it in the calculator again. Go into math, option 4, or you can scroll down to 4 and hit enter. And then we're typing in 3,750, enter. That is about 15.5. This is approximately 15.5. It's approximate, so let's leave it as the cube root when we substitute it in for our surface area, which is 4 pi r squared. 4 pi, our radius was the cube root of 3,750, and then we'll square it. So here we go, typing it in, 4 pi times the cube root of 3,750, and your cube root, and then square it. Enter, we get 3,033.17. to the nearest square meter. So that is approximately 3,033 square meters. If you round up here, you will get a different answer. That shows why it's so important to use an exact answer as far as you possibly can. Okay, let's take a look at our last section. Our very last section, 11.7, is comparing lengths, areas, and volumes of similar solids. So our objective is to find the perimeter and area of similar polygons and to compare and find areas and volumes of similar solids. So remember, when we have similar solids, we can compare them because they are the same shape but different sizes. So when we find a scale factor from A to B, that's from A to B, we can substitute in one of the sides or one of the values from that shape and compare it to the same value of the other shape. So if I want to find the scale factor from A to B, I can take the side from A and compare it to the side from B. That's 2 to 4. But when we do that, we do also want to reduce. So 2 to 4, also written as 2 to 4, reduces to 1/2. So our scale factor here is 1/2. In order to find the ratio of the perimeters of square A to square B, we need to find the perimeters of each. So to find the perimeter, I have to add up all the way around. So it's 2 plus 2 plus 2 plus 2. That gives us 2 times 4, which is 8 inches. I should have written it sideways because I'm going to write something else underneath, but that's okay. Our perimeter here, 4 and 4 and 4 and 4. So that's 4 times 4, or 4 plus 4 plus 4 plus 4, which gives us 16 inches. So perimeter, square A to square B. Starting with square A, that was 8 to 16. We can also write that as 8 over 16, which reduces to 1/2. Notice that those are the same. So the ratio of the side lengths is the same as the ratio of the perimeters. When we look at the areas, so to look at the area of the square, I take length times width. 2 times 2 is 4. And to find the area of this square here, I take length times width. That's 4 times 4, which is 16. So again, A to B, that's 4 to 16, and 4 over 16 reduces to 1/4. These are not the same, 1/2 and 1/4. As a matter of fact, the relationship that we have here is that 1/4 is 1/2 squared. And we can see that relationship because area is units squared. Perimeter is just units, or units to the first power. And a scale factor is taking in just distance, which is also units to the first power. So what we end up with is a ratio, which we can call the scale factor, A to B. And the ratio of the perimeters is that same scale factor. And the ratio of the areas is A over B squared, two-dimensional. We can also write this as A squared over B squared. They mean the exact same thing, but one might be easier to use than the other in certain situations. So let's look at how we can apply this. In example 1, we want to find the ratios of the similar figures. Give the ratio of the perimeters and areas from smaller to larger. So smaller to larger, this is going to be 6 to 8. Smaller to larger, so 6 over 8 reduces to 3/4. Now, a ratio does not have units because I'm dividing centimeters by centimeters, so the units cancel out. No units for a ratio. Give the ratio of the perimeters and areas, go from smaller to larger. So I'm going to start by looking at the ratio of perimeters is the same as the scale factor. And so to find the ratio of the perimeters from smaller to larger, I can look at small over large. Small over large. And so that is 6 over 9, which reduces to 2/3. That is the ratio of the perimeters because the perimeters have the same ratio as the scale factor. Right? Perimeter is the same ratio as the scale factor. For area, we don't actually have to calculate the areas because now we know that the area is that same ratio squared. So for area, we take that ratio, 2/3, and square it, which means we take 2 squared over 3 squared, which is 4/9. Without having to find the areas, we know the ratio. So let's see if we can use that fact. The area of the smaller regular pentagon, that's this one, is 27.5 square centimeters. What is the best approximation for the area of the larger? So this is area. I'm going to find the area here, call it X. Well, I don't know the relationship between these areas, but I do know the relationship between the sides. I'm going to start by putting my unknown side on top. So I'm going to say the ratio of the perimeters is 10/4, which is 5/2. If you put small over large, you'll get the same answer, but it will take an extra step later on, and I'll show you where that step comes in. So I'm going to put my unknown side as my numerator. So 10/4 simplifies to 5/2. That means the ratio of areas is 5/2 squared. 5 squared is 25. 2 squared is 4. Now the reason we wanted to find that ratio is because I have two areas that should be equal to that ratio. So I can say this ratio, 25/4, should be equal to the ratio of my areas. I did my larger area on top, and that means that X will go in the numerator. Now the reason this is helpful is because now, in order to solve for X, I don't have to cross multiply. I can just multiply by the denominator. So multiplying by 27.5 on both sides, you should find that X equals 171.9 squared centimeters. If I had done the proportion the other way, so I put small over large, the only difference would be you have to cross multiply at this step before you can solve for X. It just gives you one more step to your solution. For number 4, we have similar triangles. What is the ratio of their perimeters given the ratio of the areas? So this time I'm not looking for solving for an X, I'm solving for a ratio, so it doesn't matter which one goes in the numerator. We can just do small over large, it really doesn't make a difference. Small over large will give us 50/98. We do want to simplify that. They're both even, so that reduces to 25/49. I can recognize those as perfect squares, so we're not going to reduce any further. And the reason is because this is A/B squared. So that tells me that A squared is 25 and B squared is 49. A squared is 25, take the square root, that means A is 5, and same here, B is 7. By this point, you should have those perfect squares recognizably memorized. And so if we have the area proportion, and we take the square root of it, we get the perimeter proportion, and so we have 5/7. Okay, sometimes it's helpful. We can say small, larger, and then we can say here we have perimeter. That would be A/B. Area is A squared over B squared. And soon we'll also have volume, which will be A cubed over B cubed. That's a little bit of a spoiler. We're going to see it in just a second, though. So if solving it this way was confusing, what you can do is you can substitute in those values into this table. So the area, after we reduced it, was 25/49. That tells me I need to take the square root in order to get my perimeter ratio. Let's look at the next page. So here we're looking for the scale factor of the radii of the cone, so the radius to the radius. So we can say cone A has a radius of 6, cone B has a radius of 9, 6/9 is 2/3. That is the scale factor. Scale factor, again, would be units to the first power. Surface area, that is units squared. And so if I know my ratio here, to find the surface area, we can take 2/3 squared to get 4/9 without even finding the area of the cones. And finally, the volume. Volume is units cubed. So we take our original ratio, A over B, but now to the third power. 2 to the third power is 8. 3 to the third power is 27. And remember, to raise something to the third power, you can use the little exponent button here right underneath clear, the little caret. So if I want 3 to the third power, it will tell me 27. So again, filling in this table, now with our new ratio, we know the perimeters is A to B, areas is A over B squared, or A squared over B squared, and volume is A over B cubed, which we can also write as A cubed over B cubed. So let's apply this. In our first example here, we have two shapes with a ratio of similarity. So this is A over B is 2 over 5. Find the perimeter ratio. Well, we said the perimeter is equal to the scale factor 2 over 5. The perimeter ratio is equal to the scale factor. The area ratio, we have to square it. 2 over 5 squared gives us 4 over 25. And the volume ratio, we take it and cube it. We're not cubing our area, we're cubing our original, our perimeter or scale factor. So we can't take this squared one and cube it. That would be raising it to the 6th power. That's way too high, right? We're taking the original ratio and cubing it. 2 cubed is 8. I wrote a 3, this should be a 5. 5 cubed is 125. Okay. Here in the next part, we're given an area ratio of 81 to 49. Area means that this is A squared over B squared. So to find A, I need the square root of 81. So that means that A is 9. B is the square root of 7, or sorry, the square root of 49. That means that B is 7. Whatever the scale factor is, also the perimeter ratio, so that's 9 over 7. And our volume, we take A over B. This is A over B. We take A over B, and volume is cubed. So that's 9/7 cubed. That one I'm going to do in the calculator. 9 cubed and 7 cubed. 9 cubed is 729. 7 cubed is 343. Now, because 9 over 7 doesn't simplify, I know that no powers of 9 over 7 will simplify. So if this original A over B fraction is completely simplified, then we don't have to worry about simplifying the rest. Okay. For example 2, we're doing similar solids. We're going to see if we can apply this scale factor. So we have two similar cylinders with a scale factor of 3 to 4. That's A to B. If the volume of the larger cylinder, 256 pi cubic centimeters, we want to find the volume of our smaller cylinder. So again, I'm going to use that trick where I put the unknown one on top. The smaller number on top, it's already on top. They did it for us. What is the volume of the smaller cylinder? Well, if I have the ratio of the scale factor, then I also have the ratio of volumes. I just have to find it. Volume is A over B cubed. So that's 3 over 4 cubed. 3 cubed is 27. 4 cubed is 64. You can always check it in your calculator. With this ratio, I know that the ratio of volumes should be equal. So again, I'm putting the smaller number on top. I'm just checking that it's on top. 27 over 64 equals our unknown over 256 pi. Multiply both sides by 256 pi. And we find that x equals 108 pi. This is a volume, so that is cubic centimeters. On number 4, the ratio of the volumes of two similar pyramids, I'm going to just call it small and large pyramid, is 343 to 1,728. That was volumes. So those are cubed. That's A cubed and B cubed. What is the perimeter ratio of the pyramid? So we want A to B. That's our goal. So in order to find this, I need to know what is the cube root of 343. Well, we have actually just found it here, right? We said 7 cubed was 343, but for practice, let's find it in the calculator. So to find the cube root of 343, we go into the math menu. Option 4 gives us the cube root. Cube root of 343 is 7. So A equals 7. Then we need the same thing, the cube root of 1,720, and we get 11.98. Sorry, that should be a 28. I thought it was an integer. So that should be 12. B equals 12. So our ratio for perimeter is A over B. That's going to be 7 over 12. I'll put here as a side note, the cube root of 343 we said is 7, and the cube root of 1,728 is 12. That's where those numbers came from. Let's look at our last page of practice. So on our last page here, we want to give the ratio of perimeters to areas for the similar figures using smaller to larger. So smaller to larger, I have here side lengths, so I can say my scale factor is 15 to 25, reducing by 5, that is 3/5. The scale factor is the same as the perimeter ratio, so perimeter is 3/5. To find the area, we have to square it. Area is the ratio squared, that is 9/25. This would be A and this would be B. On number 2, find the area of the other figure to the nearest whole number if the area of the larger trapezoid is 121 square meters. We'll call this area X. I have side lengths, but I don't have the area of those trapezoids, so I can use the scale factor. I'm going to put the one with my unknown in the numerator, so that's 12 over 18, reducing by 6, that is 2/3. That's A over B. So for area, I need to do A over B squared. That's 2/3 squared, giving us a ratio of 4/9. I can take that area ratio and set it equal to my actual areas. So 4 over 9 equals X over 121. Multiply both sides by 121. Reduces, and we get that X equals 54 square meters. Of course, rounding to the nearest whole number, as it says in the instructions. For number 3, we want to find the area of the other figure to the nearest whole number. I'd like to let you go ahead and try this. It's very similar to the one that we just did. So this time we have the area of the smaller hexagon being 23 square meters. That means the area of our larger shape is unknown. Let's start by finding the scale factor. Our unknown in the numerator to make it easier later on. So that is A over B, area, A over B squared. So that's 11 over 3 squared. 11 squared is 121. 3 squared is 9, giving us our ratio of areas. So we can set that equal to our ratio of areas. 121 over 9 equals X over 23. Multiply by 23 on both sides. We should get that X is about 309 square meters. For number 4, we have 2 similar cones. Here's one. Here's a larger one. The ratio of the volumes is 27 to 64. Volumes, 27 to 64. If the larger cone has a surface area of 112 pi square meters, find the area of the smaller cone. So this is a little tricky because we're going from volume to area. And in order to go from volume to area, we need to stop at the scale factors. So let's take first our volume. Volume is A over B cubed, and that is 27 over 64. So I need to know what cubed is 27. 27 is A cubed, so A is the cube root of 27, which is 3. Likewise for B, B cubed is 64, so B is the cube root of 64, which is 4. That gives me a scale factor of 3 to 4. Or my perimeter is 3 to 4. To find the area, I take A over B squared. So that is 3 over 4 squared, giving us 9 over 16. So now that I have that ratio, I can set it equal to my given areas. 9 over 16 equals x over 112 pi. Multiply both sides by 112 pi. And we find that x equals 63 pi. It's an area, so that is square meters. For number 5, we have 2 similar cylinders. There's one, there's a larger one, with radii of 5 and 6 centimeters. Find the volume of the smaller cylinder is 250 pi cubic centimeters. Find the larger volume. So I have here the scale factor is 5 to 6. Volume is 5 to 6 cubed. 5 cubed is 125. 6 cubed is 216. So I take my known ratio, set it equal to my unknown ratio, and I actually want the larger number on top, so I'm going to reciprocate this. 216 over 125 equals x over 250 pi. And so I can solve for x, multiply both sides by 250 pi, and x equals 432 pi centimeters cubed, cubic centimeters. And finally, 2 similar pyramids have lateral areas of 8 feet squared to 18 feet squared, small and larger area. That's 8 to 18. If the volume of the smaller pyramid is 32 cubic feet, find the volume of the larger. So similar to what we had done in the problem immediately above this, except for backwards. This time we're given area, we need to find volume. I want you to go ahead and give this a try, and then we'll go through it together. So for this one, we have area, that's A over B squared is 8 over 18, which reduces to 4/9. That tells me A squared is 4, B squared is 9. The square root of 4 is 2. The square root of 9 is 3. Volume, sorry, that was area. Volume is A over B cubed. So that's 2/3 cubed, giving us 8 over 27 as our ratio. Here I want the larger to be on top. I'll set it 27 over 8. equals x over 32. Multiply by 32 on both sides, and we get that x equals 108 cubic feet. Okay, the last page here in the notes packet is really a cheat sheet, a place that we can put all of our formulas for volume. Volume of a cylinder, volume is always base times height, area of the base. Well, the area for a cylinder, volume equals pi r squared h. For a prism, there's no shortcut for the base because I could have any base, just base times height. For a cone, that's 1/3 of a cylinder, so volume is 1/3 pi r squared h. For a pyramid is 1/3 of a prism, 1/3 base times height. And finally, our volume for a sphere is 4/3 pi r. Volume is cubed. Just as a reminder, if the base is a rectangle, we have base times height. If it's a triangle, it's 1/2 base times height. If it's a polygon, the area of the base is 1/2 AP. And then our summary of the last section, if we have the ratio of sides A over B, that's equal to the ratio of perimeters, which is the ratio of areas squared, and the ratio of volumes is cubed.